So, good afternoon, everyone. Welcome you all for NTA lecture. So, in the previous lecture, we have discussed about the final value theorem, which will help us to find out the transient response as well as steady state response of RL circuit and RC circuit by using the initial conditions and final conditions. So, we have discussed the 6 steps in the final value theorem to find out the current response or voltage response, I of t as well as V of t. So after that, we have solved 2 examples based on that final value theorem. So in that, one example was based on RL circuit and second example was based on RC circuit. Okay, so 2 examples we have solved. So when we have to select this final value theorem for solving the such an example. So we have to observe the circuit. If in the circuit multiple resistors are present, then you can go for final value theorem, as well as if in the circuit or if the circuit is parallel circuit or series parallel combination like this, then also you can use the final value theorem. If circuit is straightforward series circuit, then you can use normal method. ओके जेव्हा मल्टिपल रेजिस्टर्स दिसतील तेव्हा तुम्ही फायनल व्हॅल्यू थेरम यूज करा. सो सच एक्झाम्पल्स ऑलरेडी सिटी क्वेश्चन पेपर, सच एक्झाम्पल्स asked in competitive examination like GATE examination or any public sector examination. So already we have discussed all these theorems steps in the previous lecture and 2 examples we have solved. But in all those examples we have taken the voltage source. But now whatever the example we are going to continue today, in this third example we are taking now, in this example there is a current source. There is what? Current source. So that how to solve such type of example when the current source is there, how to find out current response, that we can discuss. So question number 3, I will just repeat again even though it is over now. Find current I of t for t greater than 0 in the given circuit. In the given circuit. So circuit diagram I will draw. This is what 10 ampere. This is 1 ohm. This is 2 ohm. This is also 2 ohm. This is 2 Henry. Inductor is given. The switch is closing at time t equal to 0. The switch S is closing at time t equal to 0. And the current passing through this branch, that is I of t, you have to find out when t is greater than 0 value. So how to start this example? First of all, which response you are going to find out, that you can observe. That is the current I of t. We have to find out in which branch that is mentioned, that you can observe. Second thing, the status of switch position. So switch is closing at time t equal to 0. After closing, you have to find out the response. Third one, observe the circuit. It is made up of RL circuit. Multiple resistors are there. 3 resistors are shown. Fourth thing is what? Current source given. That is the ideal current source or practical current source. If you are combined taking here 10 ampere as well as 1 ohm. If you are going to take, it is acts as a current source. तुम्ही या प्रॅक्टिकल करंट सोर्सचं कन्वर्शन प्रॅक्टिकल व्होल्टेज सोर्स मध्ये पण करू शकता by using source transformation, but I will take as it is. Okay, now when multiple resistors are there, series parallel combination is there, then I will use the final value theorem to find out the current response. Okay, current transient response I of t. So first of all, the step is when switch, according to the new position of switch, I will draw the diagram. When switch yes at t equal to 0. So according to the new position of switch, I will draw the diagram here. So this is what 10 ampere. This is 1 ohm. The switch is closed here at t equal to 0. This is 2 ohm. This is 2 ohm. And inductor is 2 Henry. So the current passing through this switch will be I of 0 plus, I will call it as, because the switch is closing at time t equal to 0. Now next step is what? The current response, because they are asking to find out the current I of t. The current I of t for t greater than 0 is given by I of t is equal to I of infinite plus I of 0 minus I of infinite bracket complete into e raised to minus t divided by 2. So this is my equation number 1. Now next, question number 3, step number 3. Time constant you have to find out. Time constant tau value. So as you are observing, this is a RL circuit. So for RL circuit, what is the equation of time constant? Tau is equal to L by R. But here R is nothing but R equivalent, because multiple resistors are there. So it is L by R equivalent. So you have to find out now R equivalent. So finding out R equivalent means you have to find out equivalent impedance observed between two terminals where the inductor you have to remove. Okay. So while finding out equivalent resistance, you have to consider the new position of the switch. So I will write that while finding R equivalent, 10 ampere current source will be open circuited. 10 ampere current source will be open circuited. Next, switch will close. Switch will close because new position you have to consider. And third one, inductor you have to keep open circuit. So according to that, you have to do it everything. So this resistor I will keep 1 ohm. This switch you have to show, which is closing. Next, this resistor as a 2 ohm. This resistor as a 2 ohm, and inductor you have to make it open, through which you have to find out the R equivalent. So can you find out R equivalent? Already we find easily we can find out R equivalent here. So R equivalent means if you are observing from right hand side and measuring from left hand side, 1 ohm is connected in parallel with this 2 ohm. That is 1 is in parallel with 2. That is in series with these 2. So if you are calculating 1 parallel with 2, 1 into 2 divided by 1 plus 2, this plus 2 as it is. So it will give 2 by 3 plus 2, that is 8 by 3. Okay, so it will give what? 8 by 3. So R equivalent you can keep 8 by 3 as it is. So 8 by 3 you can put in the time constant. So tau value is equal to L by R equivalent. So that is equal to 1 by 8 by 3. So that will give 3 by 8 second. I will keep as it is. Now next, fourth step is what? You have to find out the initial condition. You have to find out the initial condition, that is the I of 0. You have to find out. After that, you have to find out I of infinite means final condition. And then everything, each and every value you can put in the equation number 1 to get the final answer. So this is about what? Up to the step number 3. Now step number 4, we can start. Step number 4, initial conditions we have to use to find out initial conditions we have to use to find out I of 0 minus equal to I of 0 plus. Okay, so according to the old position of switch, so this is what 10 ampere current source. This is 1 ohm. Now switch was open when the time t is less than 0. So this is what 2 ohm. This is what 2 ohm. So inductor, if it is not connected to 10 ampere current source for long time, it will act as automatically open circuit. Okay, because inductor having no charge initially. Inductor does not have any charge initially, and current is also 0. So due to which what will happen? The through inductor becomes 0 ampere, and if current is 0, then practical meaning is that what? The inductor is 0. Inductor acts as an open circuit. So I of 0 minus is equal to 0 ampere. So I will write each and every explanation here. As no charge initially on inductor, as well as 10 ampere current source is disconnected. Current source was disconnected for t less than 0. The current flowing through, म्हणजे हे दोन कंडिशन्स आहेत, एक तर चार्ज नाही इंडक्टर वरती आणि दुसरा काय 10 ampere current source is disconnected from the inductor. So due to which the current flowing through inductor, the current flowing through inductor is 0 ampere. That is I of 0 minus is equal to 0 ampere. But when you are closing the switch, when switch will close, at t equal to 0, the current flowing through inductor remains same. The current flowing through an inductor, remains same. That is I of 0 plus is equal to I of 0 minus remains same. That is equal to 0 ampere. Okay. So current flowing through inductor remains 0 ampere for some time, even though switch is closed. And after some time, then constant current will flow. And according to the circuit, the new current will flow through the inductor. Okay. त्याच्यात थोड्या वेळानंतर 0 प्लस पर्यंत तो 0 अँपिअर राहणार, पण काही वेळानंतर तो कॉन्स्टंट करंट देणार. नाउ okay, now the next we have to find out the final conditions, that is the I of infinite. So final conditions to find out I of infinite at t equal to infinite. Okay, so this is happening what? When switch remains closed for long time. When switch remains closed for long time, म्हणजे स्विच क्लोज झाल्यानंतर खूप काय होणार, कॉन्स्टंट करंट फ्लो होणार सर्किट मधून, आणि तो करंट तुम्हाला आय ऑफ इन्फिनाइट म्हणून फाइंड आउट करायचा. ओके, सो दॅट वी कॅन फाइंड आउट नाउ. So this is what 10 ampere current source. This is 1 ohm. The switch you have to show as a close and t equal to infinite, t is greater than 0, you can consider. This is what 2 ohm. This is what 2 ohm. Now, what is the position of inductor when the switch is connected to power supply for a long time, whether it is short circuited or open circuited?
Short circuit.
Yes. So once the inductor is connected to supply for a long time, if constant current will flow, then it acts as a short circuit. So inductor acts as a short circuit here. Okay, at t equal to infinite. So already I told the table in the previous lecture. So once the inductor becomes short, now you can find out this current as a I of infinite. So how to find out this current now? How to find out this current? Yes, anyone? There is a two method. One method is what? This is what the practical current source. You can convert into practical voltage source. Okay. And then apply nodal. So instead of that, what I will do, I will apply the nodal analysis. So here one node is there and is no component here anywhere. So same voltage is there at this point also. So only one voltage is there. So V. Okay. Vx म्हणूया किंवा Vx करूया. So same voltage is there because here no component is there, no passive components in between this. So this is incoming 10 ampere. This you have to mark outgoing. This you have to mark outgoing, and this is already outgoing. So I will apply nodal analysis. Apply nodal analysis here. So apply KCL at node V. Apply KCL at node V. Assume that V is greater than 0 for all these three branches, 1 ohm, 2 ohm, and 2 ohm. So first current is incoming, that is minus 10. Next plus Vx, assume Vx paisa right? Vx divided by 1 plus Vx divided by 2 plus Vx divided by 2 is equal to 0. First of all, I will find out Vx, then I of infinite. आता Vx minus 10 तुम्ही इकडे घ्या right hand side ला, that becomes 10. Here LCM is, you can take 2. This is 1. This is 1. So LCM you can take as a 2. So here also you can multiply if you want. Okay. So 2 into minus 10 is minus 20 plus 2 into Vx plus 1 into Vx plus 1 into Vx divided by 2, but right hand side is 0. Now Vx plus 2 Vx, that is 4 Vx. Minus 20 goes to the right hand side, becomes plus 20. So Vx is equal to what? 5 volt. Once you can get Vx, now current I of infinite. Current I of infinite you can get Vx by this 2 ohm. If you are doing, you can get that current, that is 5 by 2, that is equal to what? 2.5 ampere. So this is what my I of infinite. So finally you got I of 0 also, I of infinite also. Now you can move towards the sixth step, that is put I of 0 and I of infinite tau value in equation number 1. Then we get, okay, so what you can get, I of t is equal to I of infinite plus I of 0 minus I of infinite into e raised to minus t divided by 2. So that is equal to I of infinite, what you get, what we got, 2.5 plus I of 0 is 0 minus 2.5 into e raised to minus t divided by, what was the value of tau value? It is 3 by or 8 by 3?
3 by 8.
It is 3 by 8. So 3 by 8 you can put here two value. So this will become 8 by 3 minus 8 by 3. So final answer I will draw here. Final answer will be I of t is equal to 2.5 minus this plus minus because minus 2.5 into e raised to minus 8 by 3 into t. So this is the final answer. And as this is the current, the unit is ampere. As this is the current, the unit is ampere. So such a problem they will ask for 6 marks, minimum 6 marks, maximum 8 marks. In the competitive examination, they can ask any one parameter. Either they can ask time constant, they can ask initial conditions, they can ask final conditions in the form of MCQ questions. Okay, so here we have covered the different types in which multiple registers are there, current source is there. That is very important thing. Okay, now next okay, one more example we can solve here. Question number 4. Determine I of t. Determine I of t for the circuit shown in figure. Determine I of t for the circuit shown in figure. Okay, so I will draw the diagram. This is not by using final value theorem, but the switch is K here. This is the A position and this is the B position. This is 25 ohm and there is an inductor 1 Henry and power supply voltage source is 25 volt. The switch is moving from position A to position B at time t equal to 0 and they are asking to find out I of t for time t greater than or equal to 0. So how to start this example? Okay, this is an extra or additional problems. It is not depends on, or this example also you can solve by using final value theorem. Even though there is no multiple resistors, you can find out by using final value theorem. By using two different methods, you can solve this. One is what? As only one inductor is there and one resistor is there, and series circuit is there. Okay, so in that case, you can use the DC response of RL circuit. According to that, also you can solve. But by using final value theorem, also you can find out. So by using final value theorem, we can try to solve it. Okay, now first what we can say, first step is when switch K is changed from position A to position B at t equal to 0, then circuit you have to draw according to the new position of the switch. So new position of the switch B, it will be at position B. this is 25 ohm and inductor L. Okay, so the current, this is when time t greater than or equal to 0. This is a K, and the current I of 0 minus is equal to I of 0 plus. Next, the current you are going to find out, that equation I will write. The current I of t for time t greater than or equal to 0 is given by I of t is equal to I of infinite minus, sorry, plus in bracket I of 0 minus I of infinite bracket complete into e raised to minus t divided by 2. So this is my equation number 1. So what is the time constant tau here? It is very simple, L by R equivalent. So R equivalent is replaced by only R. According to new position of the switch, if you are considering here, L तुम्ही open करू शकता. So time constant tau is equal to L by R equivalent. So L by R equivalent is nothing but only R. Okay, कसं सांगू का, new position of the switch I will tell. This is at B position. Resistor will be 25 आणि inductor तुम्हाला open करायचं. So you have to observe the R equivalent. So R equivalent is nothing but only R, and that is nothing but 25 ohm. So tau value is, L is nothing but 1 Henry divided by R equivalent is nothing but R, that is the 1/25, that is second. Keep as it is. Now, next one, fourth step will be finding out initial conditions. Initial condition. To find out I of 0. Initial condition to find out I of 0. So I of 0 we have to find out means when the switch was at position A. So according to that, you have to draw the diagram. This is 25 volt plus minus. The switch is at position A. This is 25 ohm. Now when the switch was at position A for long time, at that point the inductor will act as a short circuit. खूप वेळ switch A वरती होता, मग A वरती म्हणजेच 25 volt connected होता. When the constant current source is connected to inductor, after some time the constant current will flow and inductor will act as a short circuit. That already we have learned. Time t equal to minus infinite or plus infinite. So inductor acts as short circuit for t is equal to minus infinite. Okay, म्हणजेच I of 0 minus which was closed before closing काय होता, at t is equal to 0 minus घेऊया आपण if you are confusion. Okay, for t is equal to 0 minus. So in that case, this I of 0 minus you have to find out. So what is the value of I of 0 minus? I of 0 minus is equal to, if you are applying simple Ohm's law, 25 divided by 25. 25 volt divided by 25 ohm, that will use 1 ampere. So even though switch K is moved or changed to position B, is moved from position A to position B at time t equal to 0, the current I of t will be same. Because inductor does not allow the sudden change in current. That is I of 0 plus is same as I of 0 minus, that is equal to not 0. Here it is 1 ampere. So that remains as a 1 ampere because inductor does not allow the sudden change in current. Inductor does not allow change in current, sudden change in current. Changing current. So this is what the important things. So we got now I of 0 plus is equal to I of 0 minus as the same, that is the previous, that is what 1 ampere current. Okay, now next thing, we have to find out the final condition, that is I of infinite. Fifth point, final condition. Final condition to find out I of infinite. So you have to show the new position of the switch. Okay, so new position of switch means B position. Switch is K. This is what 25 ohm. So what will happen when the switch is remaining at 0 volt? Hey, 0 volt, hai na? There is no source, means 0 volt. Okay, so what will be the value here? What will be the value here? I of 0. झिरो वोल्ट असल्यामुळं करंट झिरोच असणार आहे ना. So whatever the 1 ampere is that current will going to decrease. Power supply 0 झाला, 25 पासून 0 झाला. So current also becomes what? 0 ampere. Okay, so the I of infinite value will become 0 ampere. So due to this inductor acts as an open circuit. So I will write as voltage source is 0 volt. The current in the inductor, reduces from 1 ampere to 0 ampere. Okay, therefore you can write like this: at t is equal to infinite, the current in the circuit, that is I of infinite, becomes what? 0 ampere. So these all we got now. So finally you can put all these values in the equation number 1. So put all these values in equation number 1. Then we get, so equation 1 I will write I of t is equal to I of infinite plus in bracket I of 0 minus I of infinite bracket complete into e raised to minus t divided by 2. So this is the equation number 1. So in that I have to put each and every value. So I of t as it is, I of infinite that we got 0 plus I of 0 we got 1 ampere, that is 1, minus I of infinite is again 0 into e raised to minus t as it is. Tau value किती आलता? Tau value is, how much we got tau value?
1/25.
Yes, L by R. L value is 1 and R is 25. So that is 1/25. So my final answer will be like this: I of t is equal to 1 into e raised to minus 25 will go to the numerator, minus 25 into t. 1 into e raised to minus 25 into t. So as this is the current, the unit is ampere. So this I got by using final value theorem. Actually, you can go for normal method because that is the series circuit. So by using the differential equation, you can get, okay. So you can get the characteristic equation, you can find out the roots, and once the roots you are going to find out, then based on that you can find out the complementary function. So by using that method also you can solve this example. In final value also you can, if the series circuit is there, you can go for normal method. As only one resistor value is here, series circuit is there, you can go for normal. If multiple resistors or parallel combination like will be there, you can use the final value theorem. But I shown by using final value here. You can try as a homework by taking the normal method. Okay, so these are the examples sufficient for this chapter. Only small point is remaining, so that we can discuss, and then we can stop for today. The final point I will discuss with the help of PPT. If any questions regarding these questions, examples you can ask. Otherwise, we can start to discuss the last point in this chapter. The screen is visible. Please reply anyone.
Yes, sir.
Okay. So hardly 15 to 20 minutes we require to complete this point, so that we can complete this chapter as well as the syllabus of this subject. So time domain analysis of linear circuit. For that we can use linear differential equation. We can use Laplace transform. Okay. Differential equation we have learned. So we can discuss now Laplace transform. Okay. So before that, some revision we can